So a quick review of oxidation and reduction. These are processes that involve movement of electrons. Oxidation is related to a loss of electrons, whereas reduction is related to a gain of electrons. And so two common ways to remember this and which direction the electrons are going. One is oil rig. Oxidation is loss, oil. Reduction is gain, rig. Okay, so oil rig, oxidation is loss of electrons, reduction is gain of electrons. Another common way to remember this is Leo goes grr, right? So loss of electrons, oxidation, Leo, gain of electrons, reduction, grr. Okay, and so remembering which process is which is going to be very important as we get into electrochemistry. When we talk about what's being oxidized or what's being reduced, we're looking at elements to start on the reactant side and then on the product side, and we're looking at what's happening with their oxidation numbers. If something is losing electrons, that means it's becoming more positive in its oxidation number. If something's gaining electrons, if it's being reduced, then we see the oxidation number going down, becoming more negative. And so when we talk about agents, we have oxidizing agents and reducing agents. And just like real estate agents or insurance agents, these are people that help to facilitate the purchase or sale of real estate, the purchase of insurance. They help the thing to occur. So an oxidizing agent contains something that is facilitating something else being oxidized. So that means that it itself is being reduced. By being reduced by taking on electrons, it's facilitating something else giving up electrons, that is oxidizing. And so the same is true. A reducing agent is going to be that species which contains the element that it itself is being oxidized, because that element being oxidized is facilitating the reduction of another species. A quick reminder of some of the rules for determining oxidation numbers. Any atom that's in its elemental state has a zero charge. Monatomic ions will be whatever the charge is on the ion. Nonmetals, oxygen is typically a -2. Hydrogen is typically a +1, but it can also be a -1 depending on what it's bonded to. Fluorine is usually a -1. And your other halogens, it really depends on what the rest of the formula is and how many oxygens are bonded with it. The sum of charges in a neutral compound should come out to 0 for a neutral compound. The sum of the charges of the elements in a polyatomic ion should come out to whatever the charge on the ion itself is. So if we look at this equation here, we're asked to identify what's being oxidized, what's being reduced, and then what's the oxidizing agent, what's the reducing agent. Okay, so here we see cadmium is by itself, so that would be 0. Oxygen is a -2. There's 2 of them, so that's going to be a -4, and so that means nickel is a +4. Right? In water, hydrogen's +1, oxygen's -2. Over on the right-hand side, hydroxide is a -1, and there's 2 of them, so cadmium here has a +2 charge. Remember, over here to start, it has 0 charge, so it's going from 0 to +2. It's becoming more positive, so that means that cadmium is the element being oxidized. If we look at the other species here, the nickel, all right, it's bonded to 2 hydroxide, so it's going to have a +2 charge. It started with a +4, so it's going from +4 to +2. Its charge is coming down, so that means that nickel is what's being reduced. So when we think about the agents, we want to now look at specifically at the species that contain these elements. All right, the oxidizing agent is going to contain the element that was reduced, that is nickel, so that would be the nickel 4 oxide, the NiO2 solid. All right, the reducing agent is going to contain whatever is being oxidized, and so that is just the elemental cadmium in its solid state. So just as you can have some insurance agents that are better or more effective than others, some real estate agents that are more effective than others, oxidizing and reducing agents are going to have varying strengths. And so one way that we can measure the strength of an oxidizing agent or a reducing agent is by comparing them using what's called standard reduction potentials. And this is usually a table of values. It contains an equation that shows the reduction of a given species, and then it assigns a numeric value, usually expressed in electron volts or EV. And we use this not only for identifying the relative strength of oxidizing reducing agents, but also for helping us to figure out the voltage or the electromotive force that is going to be generated in a voltaic cell. And so when we look at a table that contains these values, the way to read it is the more positive the standard reduction potential value is for that given species, the greater the tendency for reduction to occur, meaning that it's going to gain electrons and hence be reduced. All right? The more negative the standard electron potential is, right, the more likely it is to be oxidized and therefore serve as the stronger reducing agent. Okay, so positive standard reduction values, right, means that it's more likely to be reduced, the element or the species, and therefore it's going to serve as a strong oxidizing agent. The more negative the value is, the more likely it is to be oxidized and therefore serving as the best reducing agent.